Hello, I'm Pete Bellotta. When it comes to a multitasking woodworking machine, the radial arm saw more than qualifies. Besides performing all types of crosscuts, a radial arm saw can be used for ripping, as well as sanding, routing, and drilling when fitted with the appropriate attachments. However, this level of versatility comes at a cost, and I'm not just referring to dollars. The fact is, radial arm saws are somewhat temperamental machines that require a lot of setup and frequent adjustment. But before we get ahead of ourselves, let's take a look at the design and operation of this time-honored power tool. A radial arm saw is essentially a circular saw suspended from an overhead trolley. The saw is mounted on a fixture called a yoke, which is attached to a rotating carriage assembly. The carriage is fitted with rollers that slide along two rails mounted on the arm. This arrangement enables the saw to move back and forth, as well as rotate 360 degrees at any point. The overhead arm is attached to a column that swings from side to side, effectively placing the saw at any angle for cutting miters. A fractional scale on top of the arm indicates the miter settings, while a knob at the front locks the arm into the desired position. The saw can also be tilted for making bevel cuts, with the cutting angle indicated on a separate scale. To adjust cutting depth, the column can be raised or lowered by turning a hand wheel at the front of the machine. Most 10-inch radial arm saws have a maximum cutting capacity of 3 inches at 90 degrees. The saw blade is powered by an induction motor, which on most 10-inch machines is rated between 1.5 and 2 horsepower. Since a radial arm saw is used for cross-cutting and rip cutting, most saws come with a 40-tooth combination blade, which is suitable for both operations. However, use a 60-tooth blade to produce a finer finish on crosscuts and a 24-tooth blade to rip cut heavy stock more efficiently. Unlike a compound miter saw, where the blade travels through an open cutting path formed by the split fence and kerf plate, a blade on a radial arm saw actually cuts through the fence and into the table. Consequently, the fence and table are sacrificial components typically made of particle board or high-density fiber board. The table consists of 3 separate pieces: the front table, which is rigidly attached to the frame, along with a spacer table and rear table. Both the spacer and the rear table float on top of the frame and perform a dual role as both a work surface and a fence clamp. For cross-cutting, the fence is positioned between the spacer table and front table. This provides maximum cross-cut capacity and places the saw blade safely behind the fence. For ripping, the fence is inserted behind the spacer table and rear table. This position provides maximum rip capacity. To make a kerf, turn on the saw and lower the arm gradually until the blade cuts into the table about 1/8 of an inch. Incidentally, if you're interested in preserving the life of the work table, attach a sheet of 1/4-inch hardboard to the surface. But instead of using fasteners, spot glue the piece in position to eliminate the possibility of a nail or screw getting in the way of the blade. In order to prevent the risk of accidental or unauthorized triggering, the power switch includes a lockout which must be inserted before the switch can be turned on. Like other types of power saws, the most obvious safety feature on a radial arm saw is the blade guard. The guard rises to expose the blade as it contacts the workpiece. Once the cut is complete, gravity causes the guard to drop down and conceal the blade. To reduce the chance of kickback during rip cutting, radial arm saws are equipped with a riving knife and anti-kickback poles. Normally during a rip cut, the material only contacts the front half of the blade. However, if the work makes contact with the back half of the blade, the material can be hurled back towards the operator at considerable speed. This condition is known as kickback. For example, when cutting wet lumber, the saw kerf may actually close up after being cut, pinching the back of the blade in the process. As a result, the blade will drive the workpiece back at the operator, resulting in a potentially serious injury. By keeping the kerf open, the riving knife keeps the workpiece clear of the table, virtually eliminating kickback. The anti-kickback pawls, which are added insurance against kickback, allow the material to move freely in the forward direction. If the workpiece binds, however, the anti-kickback pawls dig into the wood, preventing it from being driven towards the operator. One of the unique safety features offered on this radial arm saw is the control cut system. This mechanism is designed to increase operator control by providing a counterforce as the carriage is pulled forward. The carriage is connected by a cable to a separate motor located on the left side of the arm. When the trigger is depressed, the motor begins pulling the cable rearward, generating resistance to the operator's pull. The level of resistance can be adjusted by rotating a thumb wheel on the front of the machine. As I mentioned at the beginning of the program, a radial arm saw can perform a variety of different functions. Just remember, regardless of how you'll be using it, make sure you're wearing a clean pair of safety glasses along with adequate hearing protection. Before making a crosscut, withdraw the anti-kickback pawls and riving knife and position the saw behind the fence. Next, place the workpiece on the table face side up and align the marked cut line with the notch in the fence. Be sure to hold the material firmly against the fence with your hand a safe distance from the blade. While standing slightly to one side of the saw, turn the power switch on and allow the motor to come up to speed. Now squeeze the trigger to activate the control cut motor and then pull the saw towards you to make the cut. When the cut is complete, release the trigger, turn the power switch off, and wait for the blade to come to a complete stop. Finally, allow the saw to return to the start position. To make multiple crosscuts at the same length, clamp a stop block to the fence at the appropriate distance. To crosscut a piece that is wider than the saw's crosscut capacity, adjust the stop block as needed and make an initial cut. Now, flip the piece over and make a second cut with the material firmly against the stop block. Before cutting a miter, raise the blade out of the 90-degree saw curve and then release the arm lock knob and rotate the saw to the desired angle. Now, tighten the lock knob to secure the setting and make the cut using the same basic crosscut procedure. As you can see, cross-cutting on a radial arm saw is relatively safe. That's because the rotation of the blade actually helps keep the work down on the table and up against the fence as the saw is pulled towards you. However, when it comes to rip cutting, a radial arm saw can be extremely hazardous unless the appropriate safety guidelines are followed. Take a look. To perform a rip cut on a radial arm saw, release the yoke pivot latch and position the saw parallel to the fence. For narrow rip cuts, the saw should be rotated so that the blade faces the column. This is known as the in-rip position. When making wide rip cuts, rotate the saw so that the blade faces away from the column. This is called the out-rip position. For maximum stability, always choose the position that allows the widest part of the workpiece to be between the blade and fence. Regardless of the saw's orientation, be sure to remove the notched fence and install a solid piece of material between the rear table and spacer. With the new fence in place, tighten the table clamp securely. Loosen the carriage lock knob and position the saw the desired distance from the fence, and then secure the knob to retain the rip cut setting. When using a blade with bevel teeth, the rip cut setting should always be measured from a tooth pointing toward the fence. Next, cut a curve into the table about 1/8 of an inch. Set the riving knife so that it just clears the table, and then place the anti-kickback paws on the surface of the material. Finally, set the hole down slightly above the workpiece to prevent it from losing contact with the table, a condition known as climbing. Now, turn the saw on and let the motor reach full speed. While standing to one side of the cut line, feed the workpiece gradually with your right hand and apply slight lateral pressure to the material with your left hand to keep it against the fence. To minimize the risk of injury should kickback occur, never stand directly in line with the cut. As you approach the end of the rip cut, use a push stick to finish the feed. Finally, push the material past the anti-kickback paws and turn the machine off. Always keep both hands a safe distance from the blade and have a push stick at the ready to finish the cut, especially when ripping narrow pieces. When in ripping, that is, the blade faces the column, the material is always fed from right to left. For outripping, when the blade faces away from the column, the material is always fed from left to right. When ripping long pieces of stock, always use an outfeed support stand or table. A radial arm saw will deliver consistently accurate cuts, provided the alignment settings are properly adjusted and those settings are checked on a regular basis. And while adjustment procedures vary between models, the purpose of this section is to familiarize you with the 4 alignment settings common to all radial arm saws, namely arm to table alignment, blade to fence, blade angle at 0 degrees, and blade to table parallelism. Warning: be sure the saw is unplugged before performing any maintenance or adjustment procedures. To check arm to table alignment, remove the blade guard, followed by the rear table, spacer, and fence. With the arm pointing straight ahead and unlocked, lower the column until the saw blade just clears the table. Also, make sure the yoke and bevel lock handles are secure. Now, place one leg of a framing square firmly against the rear edge of the table and the other leg against the blade. With the square firmly on the table, move the saw backward while observing the blade path. If the blade rides up on the square rather than running parallel to it, the arm is not perpendicular to the table. To align the arm, loosen the 3 set screws at the rear of the column. Now, rotate the arm as needed so that the blade runs parallel to the square. Secure the arm lock knob and tighten the set screws securely to maintain the adjustment. Finally, set the miter scale indicator to 0 degrees and recheck the alignment. To ensure that the blade is perpendicular to the table at 0 degrees, begin with the blade slightly above the table and then secure the arm, bevel, yoke, and carriage locks. Next, stand a framing square on the table with the short leg resting against the blade. Be sure the square is positioned between 2 teeth. If a gap exists between the square and blade, remove the bevel index cap to access the 4 adjustment screws. Loosen the screws and then rotate the motor slightly in the appropriate direction. Now, tighten each screw slightly to hold the position and then recheck with the framing square. Once the gap is gone, tighten each of the screws securely. Complete the adjustment by resetting the bevel indicator to the 0 degree position. The next alignment check we're going to make will determine if the blade is perpendicular to the fence. Now, we've already aligned the blade to the table, which means that our cuts will have a nice square edge. However, if the blade to fence alignment is off, not only will the cutting angles be out of whack, the potential for kickback will be far greater. With the arm locked in the 0 degree position, pull the saw all the way forward and secure the carriage lock knob. Next, place the short leg of the framing square against the fence and rotate the square upward until it is angled 45 degrees relative to the table. Be sure the square is positioned between 2 teeth. If a gap is visible between the blade and square, remove the right-hand carriage cover to access the adjustment bolts. Next, release the yoke lock handle and slightly loosen the 2 adjustment bolts. Now, rotate the yoke assembly until the gap is closed and then secure the yoke lock handle. Finally, tighten the 2 adjustment bolts and replace the carriage cover. Now we're going to check to see if the blade is parallel to the table. This adjustment is vital for achieving precise horizontal cuts. With the arm still locked in the 0 degree miter position, raise the blade at least 2 inches above the table. Next, release the bevel lock and turn the motor to 90 degrees and then secure the lock to maintain the position. Now, place the long leg of the framing square under the blade. Lower the blade until it contacts the top edge of the square. Once again, make sure the square is not contacting any teeth, and then check for a gap between the blade and square. If a gap is present, loosen the bevel lock lever, followed by the rear motor mount nut. Using a flat blade screwdriver, rotate the cam adjuster until the gap disappears. Although a radial arm saw can perform many different functions besides ripping and cross-cutting, our purpose in this program was to provide you with the basics for operating this versatile power tool. As always, consult the operator's manual that came with the tool for more detailed information. Now, let's review the key points of the program. Since a radial arm saw is used for cross-cutting and rip cutting, most saws come with a 40-tooth combination blade, which is suitable for both operations. However, use a 60-tooth blade to produce a finer finish on crosscuts and a 24-tooth blade to rip cut heavy stock more efficiently. To make multiple crosscuts at the same length, clamp a stop block to the fence at the appropriate distance. For narrow rip cuts, the saw should be rotated so that the blade faces the column. This is known as the in-rip position. When making wide rip cuts, rotate the saw so that the blade faces away from the column. This is called the out-rip position. For maximum stability, always choose the position that allows the widest part of the workpiece to be between the blade and fence. To minimize the risk of injury should kickback occur, never stand directly in line with the cut. As you approach the end of the rip cut, use a push stick to finish the feed. When in ripping, that is, the blade faces the column, the material is always fed from right to left. For out ripping, when the blade faces away from the column, the material is always fed from left to right.